Section 5.4, Subsets and Permutations. Before we go any further, please pause the video and go to Section 5.4 in our textbook and write out the following definitions. Subset and permutation. A coalition can be described as a set of players taken from the set of all voters in a voting system. So a coalition is a subset of the set of voters. For example, a set capital A is little a, little b, and little c. This defines the set A. Can you think of some subsets of capital A? Here's the complete list. The one-element subsets, the set little a, the set little b, the set little c. The two-element subsets, the set AB, the set A and C, the set B and C. And then the special case subsets. A and B and C is one, and then the empty set is the other. 8 subsets in all. That is 8 subsets, the last 2 of which are a bit different than the others. The second to last subset is equal to A itself, and is called the improper subset of A. The last subset is the empty set, denoted by the empty set symbol. By definition, the empty set is a subset of every set. Using what we now know, let's build some subsets. How many subsets do each of these sets have? Well, the set A has 2 subsets, A and empty set. The set 1, 2 has the set 1, and then the set 2, and the set 1, 2, and empty set, 4 subsets. The set ABC, this is the one from our first example, has 8 subsets. Do you notice a pattern? Every time we add an element, we double the number of subsets. 1 element, 2 subsets. 2 elements, 4 subsets. 3 elements, 8 subsets. This pattern holds true no matter how many elements in a set. If n is the number of elements in a set S, then the number of subsets of S is 2 to the n power. Now that we can count subsets, we can count coalitions. The only difference between the count of subsets and the count of coalitions is that for coalitions we don't count the empty set. This means there is always one less coalition than there are subsets. Any set of voters with n voters has 2 to the n subsets and 2 to the n minus 1 coalitions. How many coalitions of 2 or more players are there for a voting system with n players? Okay, 2 or more means not just 1, right? So this means all the coalitions except the single player coalitions. If a system has n players, how many one-player coalitions does it have? Well, each player is its own one-player coalition, so n players means n one-player coalitions. Let's see what this gives us. The total number of all coalitions is 2 to the n minus 1. To get the count of coalitions of 2 or more players, subtract off the n one-player coalitions. This gives us the count of 2 or more players of This gives us the count of coalitions of 2 or more players, 2 to the n minus 1 minus. Let's look at sequential coalitions. Remember that a voting system with n players has n factorial sequential coalitions. What happens if we require that one of the players be in a certain position in every coalition? For example, in a voting system with 6 voters, what if we require that player 6 always be in the 6th position? What if we require that player 6 always be in the 3rd position? How many possible coalitions would we have in each of these cases? Think about it this way. If we lock down player 6 into one fixed position, that leaves 5 players that can move around into any position. In other words, this is the same situation as if there were only 5 players. Since P6 can't move, it doesn't help create any more possible different orders for the set. Fixing player 6 left us with 5 factorial possible sequential coalitions. Whenever the position of a player is fixed, the number of possible coalitions is equal to the factorial of the number of unfixed players. In other words, if there are n unfixed players and we fix the position of one player, then there are n minus 1 unfixed players, so there are n minus 1 possible sequential coalitions. Example, if there are 8 players and we fix the position of one player, then there are 7 unfixed players and 7 factorial possible permutations left, which is the same as 7 factorial possible sequential coalitions. If we fix the position of 2 players, that leaves 6 unfixed players and 6 factorial possible sequential coalitions. Okay, let's do something a little different, working with factorials. There's a pattern that can be used in calculations with factorials. 5 factorial equals 1 times 2 times 3 times 4 times 5. Right? That's just the definition of factorial. Let's add in a set of parentheses. Right? Put parentheses around the 1 times 2 times 3 times 4. 1 times 2 times 3 factorial times 4 is 4 factorial, right? Since they're equal, just replace the 1 times 2 times 3 times 4 with 4 factorial. So 5 factorial equals 4 factorial times 5. In general, n factorial equals n minus 1 factorial times n. Another example, 12 factorial equals 11 factorial times 12. We can do it again. 11 factorial equals 12 factorial. 11 factorial times 12 equals 10 factorial times 11 times 12. So if you put this together from beginning to end, 12 factorial equals 10 factorial times 11 times 12. Now let's use this in a calculation. Find the value of 12 factorial divided by 10 factorial. Let's do this one step at a time. 12 factorial divided by 10 factorial equals 11 factorial times 12 divided by 10 factorial. Now 11 factorial times 12 divided by 10 factorial equals 10 factorial times 11 times 12. Find the value of 12 factorial divided by 10 factorial. Let's do this one step at a time. The first 2 lines will be a repeat of what we just did. 12 factorial divided by 10 factorial equals 11 factorial times 12 divided by 10 factorial. Then 11 factorial times 12 divided by 10 factorial equals 10 factorial times 11 times 12 divided by 10 factorial. Notice that 10 factorial is a factor in both the numerator and the denominator. We can divide out the 10 factorial. So 10 factorial times 11 times 12 divided by 10 factorial equals simply 11 times 12. Once you divide out the 10 factorials, all you have left is 11 times 12. That equals 132. This means that 12 factorial over 10 factorial simplifies down to 11 times 12, which is 132. Let's jump into our questions for this section.
Question 1. For a weighted voting system with 16 players, A, find the total number of coalitions. When the question does not say Shapley-Shubik or sequential, then the coalitions are Bonzaf style. 16 players in this one. I will use the caret symbol to designate exponents. 2 to the 16th equals 65,536 subsets. To find the number of coalitions, we just subtract 1. 65,536 minus 1 equals 65,535. B. Find the number of coalitions with 2 or more players. This means exclude the single-player coalitions. There are 16 players, which means 16 single-player coalitions. The number of single-player coalitions always equals the number of players, which in this case is 16. We have 535 coalitions minus the 16 single-player coalitions leaves us with 65,519 coalitions with 2 or more players. Question 2. Consider a weighted voting system with 10 players. Find the number of sequential coalitions in this weighted voting system. For sequential coalitions, the number of coalitions is n factorial. 10 factorial equals 3,628,800 sequential coalitions. Part B. How many sequential coalitions in this system have player 8 as the first player? 10 players to start. We're going to fix 1 player. That leaves us with 9 unfixed players. The number of coalitions then is 9 factorial. 9 factorial is 362,880. How many sequential coalitions in this system have P6 as the last player? This is really the same as Part B. We have P6 as the last. Part B was P8 as the first. All that matters is how many unfixed and fixed you have. 10 unfixed players minus 1 fixed player leaves us 9 unfixed players. 9 factorial possibilities is the number we get then. Again, 362,880. Part D. How many sequential coalitions in this system do not have player 1 as the first player? Now they're getting tricky. Instead of asking us how many have player 1 as the first player, they're asking us how many do not have player 1 as the first player. Let's reword this in a way that matches up with things that we already know how to compute. What is the total number of coalitions minus the number of coalitions that have player 1 as the first player? Let me say that again. What is the total number of coalitions minus the number of coalitions that have player 1 as the first player? Can you see that this is the same as the question for D? We start with the total number, and we're minusing the part the part we don't have. Player 1 is the first player minus the number that have player 1 as the first player. 10 factorial total is the total number of coalitions minus 9 factorial is the number that have player 1 as the first player, right? 1 fixed player. So 3,628,800 minus 362,880 equals 3,265,920. Done. This concludes our videos on power distributions.